So beginning with database corruptions. Now, have any of you ever, some people never see a corrupted block. Have you had to deal with corrupted blocks ever?
No, I haven't.
No.
Yeah. Some sites run for years and never see a corrupted block. Other sites see them all the time. So we need to be aware of how to identify the problem, how to diagnose it, and even how to fix it. So, let's have a look at it. Now, so we'll see how to detect corrupted blocks. The DBMS Repair facility, it doesn't repair anything. It doesn't repair anything, it's misnamed. But it can sometimes be of assistance if you do have corrupted blocks. But what really matters is using RMAM, which of course is the way you're going. DBMS Repair, there's still a place for DBMS Repair, but it dates back to before RMAM existed. So there's a place for it, but I'll demonstrate it, but it goes back a long way. RMAM is the way to go. Now, you've got two possible forms of block corruption. The disk itself can be damaged. Now, that should never happen. That should never happen. And more, people are using SSDs. There's a project I'm being sent to Colorado next month. It's an interesting project. And the project there is largely based on OVM, the Oracle virtualization platform. And they're running on Hewlett-Packard machines, huge Hewlett-Packard servers, and they don't have disks at all. All they've got is massive SSDs. That's going to change the way corruptions will occur hugely. Mm-hmm. But with magnetic disks, yes, certainly historically they could get damaged. But that's happening less and less. This is the actual sectors themselves on disk get damaged. You should never see that, because all hard disks have built-in error correction facilities. And it's worth asking your system administrators whether your disks are using 512-byte sectors or 4 kilobyte sectors. 4 kilobyte sector disks are much more reliable. So talk to your system administrators and ask about 512-byte sectors, which is all we ever had for decades, or if your hardware can be configured to use 4 kilobyte sectors. The bigger sector sizes are much more reliable because within each sector you have more bytes available for error checking and error correction. And Oracle strongly advises 4 kilobyte sectors, but unfortunately it's not something you can convert to. You have to reconfigure. If the disk can do it, it's going to have to be completely reformatted with a low-level format. So you should not be seeing physical damage. But yes, it can still occur. What happens more often is logical damage. The block formatting gets corrupted in some way. Now, why would that happen? Typically, it's bugs. Oracle doesn't have bugs. No, Oracle just has features that aren't fully documented. But it could be bugs. Maybe Oracle itself is damaging the block formatting as database writer writes blocks. It could be something on those lines. Maybe it's some operating system damage or some file system problem. Perhaps somewhere in the line from Oracle instance to disk as we're going through fiber channels and all the rest of it. Maybe there's some problem coming in at the hardware level there that's damaging the block write as it goes to the disk. So typically it's going to be bugs. But either way, the data in the block is lost. Physical damage, the operating system can't read it. And Oracle can do nothing about that. Oracle can do nothing about physical damage. It can report the error, but all you can do is restore the file from backup to another location. In the old days, I used to have to do this not infrequently, like once a year maybe. If you've got a file sitting on a damaged bit of disk, but a disk that's gone bad, you would just rename the file to "this file is damaged," and then restore to somewhere else on the file system, and replace the disk as soon as you can. Because if one block's been physically damaged, there's probably something horrible happening in the hardware that's going to damage more later. But there's basically nothing you can do at the Oracle level for physical damage. Logical damage is a different matter. That's where Oracle may be able to repair the damage, possibly even with zero downtime, because we can do individual block restore and recover. You could never do this with user-managed backups. With a user-managed backup, the granularity of your restore is the data file. Your operating system can't look inside a data file and say, oh, that little Oracle block's damaged, I'll just replace that. Oracle can do that because, of course, RMAM is Oracle aware. It understands the block formatting. So that's what we're dealing with. Logical damage is almost certainly what you're likely to get, but some sites will never get it. So this is what you need to be doing to minimize the possibility of block damage. Now, parameters. Show parameter db block. Now, these are on default, and default is what you will want for 99% of the case of the time. db block checksum. What that does, and the exact values for this vary from release to release. You've got off, typical, full. Typical, I think, came in release 11, if I remember correctly. You can also use, I think, true or false, also legitimate. It all depends on the version, exactly what's going on. With it on typical or full, database writer will compute a checksum whenever it writes a block to disk. Then when your server process reads the block back, it will validate the checksum. So that is going to detect any corruption that occurred while the block was on disk. Good idea. Good idea. So if the block were damaged when database writer wrote it, or somewhere in the chain of flow through fiber channels and so on, or maybe while it was sitting on disk and then wasn't read for another 3 months, that's going to be detected if the damage occurs while it's on disk, or indeed in the path to and from disk. Good idea. Then there's db block checking. That defaults to false. db block checking, or false in release 12, off in earlier versions. db block checking, if you put that onto true, which is equivalent to full, if you put that on true, that will allow checking of blocks when they're accessed in cache. So you read the block from disk, and at that point, of course, this kicks in, and you put it in the cache. And from then on, every time that block is accessed in memory, the block is scanned, checksums computed. And depending on whether you set it to low, medium, or full, there's various degrees of checking. The overhead for this is known to be significant. It's known to be significant because it's done in real time. When your server process is reading or writing that buffer in memory, all this checking is going on. And the docs talk about possibly up to 15% performance overhead. I don't know how they calculate that 15%, but it is significant. Now, so when would you do this? Typically, you would do this if you're getting problems with corrupted blocks. Perhaps if you're getting strange Aura 600 messages, or indeed the corrupted block message, which I'll show you in a moment. If you're actually getting frequent errors, probably Oracle support will ask you to set this so that they can perhaps track down when the error is occurring to work out perhaps which patch you need to apply, or what SQL operations it is that are causing the corruption on your platform. So defaults for these are usually what you will want. Here's a by-the-by. When you need to know this, if you're doing your Oracle Certified Professional exams, whenever you set these parameters to, they are always in effect on true or full for the system table space, and you can't control that. DataGuard, which you're not using yet, but I hope I can persuade you to use if I get the opportunity. DataGuard has a couple more. DB Lost Write Protect. This is an interesting one. It is theoretically possible, and not theoretically, it is in fact possible, on some hardware for writes to be lost. So database writer issues a write request. It's going to check points and blocks to disk. Database writer gets those blocks, writes them to disk, and they don't make it. The acknowledgement comes back to database writer, yes, it's written, but it wasn't. I am at a loss to understand how that can occur. And I used to, in years gone by, decades ago, my job was in system administration, but it's been many, many years since I was a full-time system administrator. And I assume this is the sort of problem you get, or conceivably can get, with modern disk array systems. You know, the way writes are buffered, umpteen layers of buffering and caching and so on. In some environments, this sort of problem can occur, that writes don't make it to disk and Oracle thinks they did. Well, DB Lost Write Protect in a data guard environment lets Oracle detect this situation. The reason I say data guard is because the detection of the situation is extremely difficult. You do your DML, database writer writes the change blocks to disk, and the write disappears. And that means the block on disk is as though you'd never done the DML. Well, how are you going to detect that? Well, depending on what the DML was, what actually happened, you might not even know it's happened. Now, you scan the table again, and it's just that your change isn't there. You can't even detect it. In data guard, you can, because with a physical standby, you've got a byte-for-byte identical copy of the database. Well, that's what your physical standby is, a byte-for-byte copy. Well, if losing a write is highly unlikely in any database, to lose a write in both the primary database and the write of the same block in the standby database, that's going to be astronomically unlikely. And in a data guard environment, data guard itself will then detect that situation. It will see that the SCN in one database is older than the SCN in the other. And that tells Oracle, hey, there was a lost write. And the correction will be automatic. So that's only data guard only, detects that situation. And these two as well. Again, in the data guard environment, the DB ultrasafe parameter comes in. Show parameter ultra. Defaulting to off. And what that does is it changes the defaults for all the other parameters. If you set DB ultrasafe to data and index, you implicitly set DB block checksum to full, DB block checking to full, DB lost write protect to full. So this changes the defaults for the others. So the exact effect depends on your release. So what have I done? I've said to allow to allow corruption, leave these on default. And that should give you what you need to detect a problem. So how do you then detect it? The dreaded message, Aura 1578. Well, I set up a little test earlier. Typically, you might get your users having this problem. And they say select star from a table. And oh no, there's the error. So, corrupted block detected. That famous message, well, no longer so famous, Aura 1578. Now, what you will do as DBA, the first thing you'll probably be doing is looking at the alert log, because that should be written out to the alert log. Now, we've got some information here. The alert log should give you more. So VI, can you remember where the alert log is? Well done.
RDBM. No.
You've missed that one level. Diag, RDBMS.
Oh, yeah.
Close but no cigar.
Oh, yeah.
It becomes second nature. And the next element? Correct, name the database. The next element? Name of the instance. And finally, yep, you got it. And there we are. It becomes second nature, trust me. Now, and then if you go to the bottom of the file, right, so I've gone to the bottom of the file, and here you see the errors. Oracle data block corrupted, there's the 1578, and diagnostic data in there, and there'll be other information, there'll be a trace file, incident details in that trace file. So you may find extra information here. It'll tell you which session hit the problem, perhaps what SQL they were running, when the problem occurred. So you do get the extra information in the trace file. Now, but we've got what we need in this case right here. This is telling us it's the 25th block of the second file. Now, I know the code I ran. I ran select star from T1. Yeah, so I know the problem. There's a problem somewhere there. Let's assume I don't know that it's table T1. Can you remember what views I would need to query to find out what object is sitting on block 25 of file 2? We did see the data dictionary views yesterday or the day before. If that's all I've got, how can I work out what database object is there? This is where we need to become familiar with navigating the data dictionary.
Data file?
That's part of it. That's part of it. DBA data files is in effect the top of the hierarchy. Each data file contains a number of extents.
Extents and segments, right?
Got it. So we've got to navigate the tree. So we're starting at the top of the tree with DBA data files, and we've got the file ID. We've got the file ID. But then we need to navigate down the tree. So what segment is that? And as you were saying, DBA segments. Because we know that any one segment is of a table space. But here, we don't see the link to the data file. We don't see the link to the data file. There's no direct relationship between files and segments, because one segment can be cut across multiple data files, and one data file can contain bits of many segments. So we've got that many-to-many relationship between these. And the view that resolves it is DBA extents. That's the one that sits in the middle. That tells us there's the join column to DBA data files. There's the join column, or join columns is 2 join columns, to DBA extents, to DBA segments, and then the extent ID, block ID, a number of blocks will tell us exactly what's going on with that. So the query to find out what is sitting on block 25 of file 2, something on these lines. Select segment name, or owner segment name, owner segment name from DBA extents. I'll put this into the chat, by the way. DBA extents, where file ID equals 2, and now it was block 25, wasn't it? And 25 between, that's the first block of the extent, and the last block of the extent is block ID plus however many blocks it is. So that will tell me what extent, or I could add another column to that. It's an extent of system.t1. So that's the table that's sitting there, or the partition, or the lob, or the index, wherever it might be. I'll just put that little query into the chat. There we go. So, having found out what the table is, what do we do next? I'm going to show you how to do it with DBMS Repair. In the exercise, you'll do it with RMAM. Now, using DBMS Repair. So, DBMS Repair, oops, you need to be sys to use it. Very high privileges here. And DBMS Repair, it doesn't actually repair anything, but it lets you make objects usable. You can create various tables depending on what you need to do. You may need to create some tables. Check object. Right. When you run check object, you give it what object you want to check. In this case, it will be system.t1. And it will scan through the object, writing out the addresses of any corrupted blocks to a table. And that table you create with admin tables. I'm not going to demonstrate all of this, but if you need to know it, because you just might need to have to do this at some point. But use that routine to create the repair table, and that then writes out the details to the table of which block it is. Then there's fix corrupted blocks. That doesn't fix anything. It marks them as being bad. It marks them as being bad. What it will do is read the repair table to get the addresses of the damaged blocks, mark them as being bad, and you then run skip corrupt blocks for that object, and from then on, Oracle will simply skip over the damaged blocks. So your data is lost, but the object will after that succeed. Basically, your scans of select star from system.t1, your scans will succeed, but all the rows in that block will simply not be in your query. So DBMS repair, well, what do? If you determine that the object's an index, drop and recreate it. Because for logical corruption, when you drop it, it's gone. And when the block is reused, because an object pushes its high watermark up over the block gets reformatted. If it's a table, well, there's that routine for marking the blocks, the bad blocks, and saying, just skip over them from now on. The rows are gone. Index is an interesting anomaly. And you'll see that in the exercise, by the way. If you've got bad blocks in a table, that doesn't mean bad blocks in the index. And you'll see in the exercise that can give you some very peculiar effects. Some very peculiar effects indeed at that point. So, what we will be able to do though, because we're using RMAM, is do block recovery. Now, provided you've got a backup, I don't have a backup by the way for that table space, I only just created it just now. But if you've got a backup, then we can repair the damage. Now, what RMAM will do, $v copy corruption, $v backup corruption, $v database block corruption. If you look at these views, that's a typo. That should be a dollar, not a percent. $v copy corruption. Now, when RMAM does a backup, it will be scanning the file. If it comes across a bad block, when doing an image copy, it will write out the address of the bad blocks to this view, which is of course a control file view. By contrast, if it hits a bad block when creating a backup set, it will populate $v backup corruption with basically the same information. However, from I think about release 10, we have the view $v database block corruption, which is a lot more useful because database block corruption, in effect, is a union all of the two views. And this tells you what you want to know, which range of blocks. Also introduced, I think it was release 10, 10.1. Also in release 10.1, we've got the ability to repair the individual blocks. And that's the command there, recover corruption list. So corrupted blocks have been detected, the addresses have been written out to this control file view, and then this command will go to the backup sets and attempt to find, well, it will find a copy of the block that is not damaged and put that back into the file and then apply redo to bring that block up to date. And the data file remains online. Right. That's what you're going to do in the exercise. Active Data Guard, by the way, which you do pay for Active Data Guard. I've been saying that Data Guard is free, Active Data Guard you pay for. But Active Data Guard will automate the process. It's quite amazing to see it do it. You simulate a corrupted block, as I've just done here, and then you query the table, and your query appears to stick for a bit, because in the background, Oracle is automatically retrieving a good copy of the block from the physical standby. So it recovers it automatically, and when that's happened, your query continues to run. It's quite amazing to see that happen. And one would hope, I have to confess, I've never seen it happen, except when I've deliberately corrupted a file. But yeah, it works then. So that's dealing with block corruptions. RMAN is your friend. There are a couple of other commands. Ideally, you'll validate your data files. That's with the DB verify utility. Windows, exit, it is dbv.exe. Linux, which dbv, it's just dbv. And dbv, there's, to get the help up, how do you get help? There it is. There's the syntax. You just tell it what file to verify. And again, you'll be doing that in the exercise. Normally, the only parameter you need to tell it which file to verify, and if you're not using 8 kilobyte blocks, you'll have to tell it the block size. To validate your backups, or from within the RMAN environment, there's backup validate. And the backup validate command will scan the data files to see could a backup be made. By default, an RMAN session will fail the moment it hits a bad block. The moment it hits a bad block. So for example, RMAN target / report schema. If I try to back up data file TS1, that's data file 2, backup data file 2, by default it fails the moment it hits the corrupted block. In the exercise you'll see the syntax to avoid that. So basically you will know the moment you get a corrupted block because your backup has failed. And we'll see later today what the log files look like, so that you'll see that information. Backup validate will be another way of detecting it. Now, having done that, let's just select star from, there you go, block 24. And that will have been populated by RMAN when it's attempted to do the backup. So that's corruption. I hope you haven't seen it so far. It could happen to you tomorrow. So usually nowadays it's bugs. It's bugs in Oracle, shouldn't happen anymore of course, or problems with the way your storage is configured. That's usually the sort of problem you get nowadays. And it shouldn't happen very often. But there are all sorts of things that can cause it. The last time I saw it extensively was one of the earlier releases of ASM. And with ASM on Sun hardware, and there were some problems with the way the disks were configured. And every now and then, Solaris would basically write some junk into the ASM volumes. And that was a problem with the way the disks were configured at the operating system level. The system administrators had done something that Oracle didn't want them to do. So usually, if you're getting corrupted blocks, it's a bug or configuration issue nowadays. And what I'd like you to do, please, is have a crack at seeing the effect. We hope you'll never see this, but you need to know how to fix it. So this is demonstrating it. Now, let's zoom in on that a bit. To set up the problem, connect to system, create a little table space. Create a table. Stick 10,000 rows into it. Index it. Find out physically where that table is. Where is that table? I hope that's what you'll see. Right. Flush your buffer cache and so on and so forth, whatever. Do a backup. I want you please do a backup at this stage. Just back up that data file. Here's an example of how to simulate a block corruption. It took me quite a long time to get this working. What I'm doing, if you're not so familiar with some of the Unix here, I'm listing the files in etc, and I'm sending the result to DD. And DD just writes into files. So my out file, OF, I'm writing to home Oracle TS1DBF, and I'm going to the 24th block, blocks being measured at 8 kilobytes. So what I'm doing is I'm writing the output of that command directly into that file, which should be something pretty serious. And then I hope that you'll see some interesting effects when you query the table. Right. Think about what's going on with those results. Think about what's happening there. Then we'll see if we can diagnose the problem. There's an example of using dbverify. There's an example of doing a backup and then forcing the backup to succeed. And having done that, and that's not going to be much good, of course, because it includes the corrupted block. But if your data file were 100 gigabytes big, you might not be too bothered that it's 1 or 2 damaged blocks. And that then should repair the damage. So that's a nice, or I think it's nice, a worked example of how to detect and solve corrupted blocks. Hope you'll never need to do that, but keep it in the back of your mind because you just might have to do it tomorrow. Okay. Any questions or comments at the moment? Or are you good to go?
We're good to start.
Okay. What I'll do is put up my timer. Where's my timer? And
hey everybody, I just chatted a link to a tutorial that John did some time ago, and the reason I thought it was relevant, if you haven't learned a formal lesson, haven't got a formal training in the Oracle storage model, what's the relationship, for example, between extents and segments and files and so forth, in that lesson 3 of that tutorial, there's a good discussion of that, so there you have it.
That's the point. We went through the storage hierarchy, the relationship of the views, DBA segments, DBA extents, DBA data files, and so on. You've got to have that hierarchy absolutely clear in your head. I told you yesterday, I'm a DBA. I normalize everything. Think of it in terms of an entity relationship diagram, and it all falls into place.